How's that? Ooh, it's right close to the edge. I think Yvonne's going to calm it down a little. Testing, testing, 1, 2, 1, 2, 1, 2, 1, 2, testing. Is that okay?
Okay.
That sounds good. Okay. Vote for Bob. You may know that there's an election going on in the UK. Well, a campaign, anyway. And one hopes, of course, that none of them get returned, because then we'd have a government we like. In case you actually are worrying who Bob is, here's Bob.
New York.
No, that's not Bob. Here's Bob. It's an active campaign to get politicians to commit to nature and not bulldozing over nature and building houses that nobody can afford, which is, of course, what the politicians' friends want to do. Red squirrel. Notice it's a red squirrel, and it's the Royal Society for the Protection of Birds. I'll just leave that one open. Okay, so Gpars remoting. I think we have a button to press here. Yeah. This is a sales pitch, except that it can't be a sales pitch because you're not going to pay me any money. Damn. It's breaking news. Except that it isn't, because I've done a version of this talk at the London Java Community Unconference last November, and also the Grooving Grails Exchange. How many people are at either of those? Okay, so for the rest of us, it's breaking news. It's new. Sadly, no, it's not new either, because it was done last July, so it's no longer new. It's improved. Yes, it's improved. We have some improvement. And of course, we all know what it is. It's Gpars, or at least a bit of it. So thanks to GSOC, Google Summer of Code, last year, I believe it's pronounced Rafał Sławik. My Polish tends to 0 rapidly, but I'm told that's how it's pronounced. And I'm not going to work out how to pronounce Alex's name. Alex Chapman, something of that sort. Apologies to him if I've got it completely wrong. He originally did a little bit of an implementation back a few years ago, and it was left fallow. And why was it left fallow? Remote objects. We left it fallow because we focused strongly on getting single JVM to work. And so what, going back a slide, what Russel has done is to take Alex's work and bring it right up to date. So we've got a lot of single JVM concurrency and parallels now there, and I suspect 1 or 2 people might be using it. More about 5 or 6. So hopefully this sales pitch is going to make the rest of you want to go out there and use this stuff. And it's not restricted to Groovy, although you need Groovy to run Gpars. You can run the whole thing from Java code, but you will need the Groovy artifact on the path to do so. So what we've got now is an extension of the whole Groovy idea from single JVM to multiple JVM around the place. And so we're using Netty as the transport layer between the JVMs, and it provides really quite a lot of that's needed. What Rafał, based on Alex's work, has done is to provide that next layer above. things we're talking about are these concepts familiar to people, sort of actors, data flows, CSP, data parallelism. Most people are looking fairly blank, which seems reasonable. You've probably come across actors. Anybody who's done any Scala will have been playing with actors. And the idea there is that you send it messages. It does something. It sends a result back. It's not quite a function, but it's all good stuff. I'm going to have to change glasses. I just can't see the board here. I'll do that. Actually, data parallelism is one that people are probably well familiar with. Map, only done in parallel. That's all good stuff. So we like that. You may have come across active objects, agents. Well, they're really just actors in disguise. So it's a different way of presenting the actor concept. Fork join, software transaction memory, also available in Gpars. But to be honest, you want to really consider these things to be infrastructure. Nice. Software transaction memory got touted by Haskell and Closure as ways of doing concurrency and parallelism. I think personally they're a level too low for general usage. So the things on this page, I think we're going to not deal with today, but they are there. So there's flags for these extra things that are going to be available. What I want to just quickly look at is this actors data flow. Really, I'm going to leave CSP and data parallelism for another day. But just in passing, I just want to mention why I want to leave data parallelism. Because this diagram tries to represent what we're doing with data parallelism. We have some collection of data, and for us in our program, in a single step, we transform all of those items. Now, if you use map, or what are they calling it in Groovy? Collect. On the grounds that map. Well, anyway, it actually comes from Smalltalk. So collect is the name used in Smalltalk, and that's the name that then got used in 2003. Never mind. I think you get the idea. We want everything to happen at the same time. If you use a sequential map, it sort of does, but you're going to do these things one element at a time on your processor. If we're doing this in parallel, then if we have enough processors, you do this one on one processor, this on another processor, this on another processor, so on and so forth. So that's the idea of parallel map. Data parallelism is another label for exactly that same thing. Now, would it be a good idea to do those on one JVM and these on another JVM? Maybe, maybe not. That's why we want to leave that one for a later date. We've got a lot of ideas to be thought about with trying to synchronize all of the data. So we're leaving that one as a single JVM operation where we know we don't have any issues. So how about data flow? How many people are actually aware of how you do things in data flow style? Not a lot. Okay, well, in which case I'll gloss over this a little bit for now and yet another sales pitch. I'm doing a workshop tomorrow on exactly this sort of stuff for people who don't know about data flow to find out about data flow and how it's different from the usual imperative and functional approaches to things. is that you're going to get inputs. So there's going to be a stream of inputs. And all of these green boxes are operators sitting there waiting for stuff to happen. There's no actual computing going on. With the arrival of data, this operator will do something and it will put data out on the output stream. And then it will go quiescent again, it will stop. So each operator is an event-driven system in itself. And generally they're sequential. If you are not sequential, you're not doing it right. So each operator, sequential activity, triggers on data in, does something on data out, after it's given the data out. That's enough of the waffle. We want code. No, nobody was saying nodding. Oh, right, well, you're going to get some code anyway. How's the font size? Okay-ish? Need it bigger? No opinion was shown, so need it bigger. Let's see. It would help if I did that first. Excellent. Okay, so this is a script, so it's self-standing, therefore we have to grab stuff. People using grab, or maybe not, but if you want to do scripts, you grab stuff. In this particular case, I'm grabbing netty, and because of the way in which class loaders work, you have to make sure that the netty is installed into the system class loader underneath everything that's going on. So grab config, really useful at this point, so that we can get netty installed into the running JVM that started the Groovy system. And then we're just picking up a particular thing from data flow area, data flow remote. So we put it into a separate package, makes it nice and easy to handle. And we've got some remote data flows in which there is a static function which allows us to create the management system for this JVM. Because the JVMs have got to talk to each other, you need a little bit of infrastructure over netty to handle that, and the create function does all the work for us. It provides us the proxy for the netty system underneath. In this particular instance, I'm going to use port 65535 for the server, so we're going to talk to it on there. And having created the infrastructure, we then ask for whatever stuff is. So these are names of things in the netty infrastructure. And I'm talking on the local host so that I can do the demo on this machine, even though there may not be a network out there. There wasn't earlier, so it's a damn good job I'd done this. But we now have a network, so we'll be able to do some fun stuff shortly. And so what we've done here is we've sent a request into the netty subsystem on wherever the server is for this item on that port. So it's fairly standard networking type thing going on. And then we've just asked for a value. So this is really trivial level synchronization. Make a connection, ask for some data. Absolutely no control stuff needed, because these are blocking calls. Here we have the blocking call that gives us the value that was there on the server. What about the server itself? Actually, that one and that, and then get some nice size on there. So again, we're just playing with these data flow variables. A variable that only takes a value when it's sent it and then delivers it on demand. We're really just showing the use of create again. The server still needs to talk to the infrastructure, and we're going to do everything on port 65535, create the infrastructure, and now set up the fact that we're going to serve. So Netty now generates a server on port 65535, and we are listening for requests. Down a bit? No. Move this down a bit. The lack of familiarity with control codes for everything here is the fact that this is a new machine. And I haven't a clue. Never mind. So we've created ourselves a one of these data flow variables, the operator, the green blob that's being talked to across the machines. And locally in the server, we just give it the value 1. There we are. We've sent in some data into the system. And it was a completely different script that's going to be asking for that value. Demo. Here we go. So here's the remote data flow client script. Well, I suppose you might not believe me that it is exactly that code. So therefore you can see that it's exactly that code, only in a very small font. We'll see if people can see it first. So let's start the server. Whoops. Mutter, mutter, mumble, mumble. Server. So it's told us that it's assigned the data flow variable value. So over here we can be a client, and we got the value 1. Down here we could also be another client. Also get the value 1. And so each of these are 3 separate scripts, 3 separate JVMs. And so we've got these things talking to each other with exactly data flow variable. It's exactly the same class name as the ones that you're using, but it's just acting over the remote. So you're just picking it out from a different package, and it's doing the work. So that's sort of introducing the infrastructure over Netty. Let's not worry too much about CSP. Nobody nodded their head when I said, does anybody know about CSP? Possibly people don't know that it's called communicating sequential processes. No, sequential. Programmers are very good at writing sequential code. So the problem of concurrency and parallelism is how do you manage sequential code? And the history of the last 20 years is people tried doing shared memory multi-threading. Wrong. Communicating sequential processes, data flow, is a way of managing sequential, easy to program systems and having them coordinate themselves easily without hard work from us. More on that tomorrow. Do you like the sales pitch there? But actors, very different way of doing things, actors. They're sort of standalone, asynchronous things. The thing about the data flow and CSP is the synchronization of those green blobs was part of the data arriving. So data arrived at the green blob, and something then happened. Here, the green blobs just sit waiting for data. But it's arriving from somewhere else, and you don't know. There's no fixed coordinate, there's no fixed communication system with actors. So it might be that this actor over here sends a message to this one, and this actor over here might send a message to that one. If you know the address of the actor, you can send it a message. And there are many actor systems on the JVM. Gpars has one. People possibly have been playing with them. But what happens if we put this actor on one processor, one JVM, and this one on a different JVM? Same abstraction, actors, but a different way of working. Instead of being simply queues on the same JVM, we've now got to have some form of inter-process communication. We're doing it over netting. Code. So let's play ping pong. We like to keep this example simple, straightforward. So let's play ping pong with actors. So we've got here a ball representing a ping pong ball, and it's just got a little bit of data that it carries with it. Some identifier so that we can check one ping pong ball from another ping pong ball. And I'm assuming that in this game we've got 100,000 different balls, and each ball keeps a count of how many times it's been hit. It's just for fun. We don't go around persecuting ping pong balls. What about a player? Come on, don't let me. What's going on here? So a player is going to be an actor. So they're all going to handle themselves independently, and we've got some ID or other, and standard sort of initialization going on here. The serializable is because we're dealing with netty, and all of these things need to be serializable to be moved around from JVM to JVM. Another class we've got here. Another serializable thing, but basically to do with players and balls and so on. Why are we doing this? It's case classes. Anyone who was in the Scala talk earlier, case classes, really cool things whenever you're doing anything to do with actors, because the type of the message can be an integral part of the message itself. And then you can use case classes to switch within the actor on what to do. We'll see an example of that in a minute. So a lot of these classes are here simply to make the code easier in the decision making. So what's the table going to do? The mouse occasionally stops talking to anything. So the usual stuff, we've got to get the netty involved, and we're going to create a remote actors infrastructure over netty. We bring in the standard actor because we just need one for this JVM. We create a proxy for all the work going on. We start to serve. We, the table, we're the server. The players are going to pass the ball to us, we pass the ball to another player. And it's standard sort of reactive type thing going on here, in that we're creating an actor, no different in terms of the code here from what you might write on a single JVM. That was one of the ideas. same way of working single JVM as multiple JVMs, as far as the program is concerned. And so the table expects the first player to turn up. Okay, so the type of the message is an important fact in processing this message. Any other type will just block. I'm not saying you can't get deadlock, and indeed live lock. What I'm saying here is that you will know very quickly, and you will know exactly where to go. And that's the big difference over the standard model of shared memory multi-threading, is you get deadlock, you haven't got a clue where it is for a start. With these ways of working, you know exactly where the points of synchronization are. You know where to go and look if ever you get deadlock. We expect a second player to turn up. Ping pong is pretty useless as an individual game, so we actually need two players to play with each other. And then once the two players are set up, we expect players to pass ball to us. So we've wrapped a ball as a player ball in order to be able to process it quickly. I've shown this code very quickly. If people want to have a look at this code, then it's all going to be on GitHub. It's currently on my server at home, but because of the lack of internet at the hotel and the lack of internet this morning, I failed to actually get the stuff up on GitHub. But we'll be able to download it from my server anyway, because it definitely is there. So I've just given a surface skim over this so people can go and have a look at it later if you want. Having had a quick intro, you should be able to then get into the code quite quickly. We should demo this. So if I go back down to this one, so I need to terminate that server. We need to terminate this little beast, that little beast. Page, actors, and we should be in the right place. So let's get the table moving. Whilst we notice the table sets itself up. You don't need people to actually do it. It's rather good. Okay, so this one will go to be player one. So player one turns up to the game. Okay, so player one's turned up. And so let's have player two turn up. Oh dear, this rally's going to get really boring. These guys are just too good. No, okay, I've had enough. Turn the telly off. Okay. Let's go up here for a bit. So we've done a little bit more code. Liking it so far? A few other little points. So we've had a look at actors and data for a little bit. I've just given you enough to go and have a look at the code later. And mentioned that CSP and data parallelism works in progress. So they will be coming along. And all this talk of NETI and multiple JVMs and multiple computers, you're probably thinking this is just standard clustering type things, and so, NETI is a standard clustering thing, so in a sense, absolutely yes. But given that, there's then going to be clearly an elephant in the room. And so there's an elephant in the room. Oh, no, there's... damn. How did Bob's cousin get in here? I have no idea. These squirrels get everywhere. The there's actually an elephant in the room. And no, that's the wrong elephant. This is the elephant. And that elephant, for those who aren't into logos, is Hadoop. If Hadoop, why do you need anything else? And the answer is because Hadoop is going. Everybody's now switching to the Spark. What was that? Failed to download the Kotlin plugin. And failed to have any way of getting... there we go. Sorry about that. Yeah, so... now what's going wrong? Excuse me, I think IntelliJ is playing silly beggars. No, it's not. It's doing the right thing. Yes. People using Spark out there? One or two. Do you like it?
Testing early phase.
Testing, okay, yeah. I haven't really done any benchmarking it yet, so I haven't got an opinion. But the market seems to be indicating that Hadoop is giving away a little bit to Spark. That Spark is an easier way of working. But it remains an elephant in the room. Why the heck do we need Gpars? I have no idea. Maybe we don't. But it was the right thing to do. Getting Gpars to do remoting for Groovy and Java using Gpars, I think was exactly the right thing to do, even if we don't have a play in the big data game. Because nobody actually knows what big data is. So we've got a facility. But there's one thing we actually do need to talk about. Service-oriented architecture as SMA clearly has to enter into this somewhere along the line, because it's all about services. And actually most people don't care about services, do they? They only care about microservices. So there's a thousandth of a service. That's not really very good, is it? However, mind you, microservices, how long has it been around? Oh, about a year. Clearly no longer trendy. Clearly, completely and totally passé. I mean, if we were in JavaScript territory, 6 weeks is a lifetime. So we're coming along now, Gpars, Pico services. Active objects, actors. It depends how you use it. A microservice really is just a way of presenting an actor in one way, shape or form. Of course, most of them seem to be working with HTTP and web and stuff like that. But that's sort of web applications, which is really boring. At least for me. Some people might have applications, but I'm really into proper networking and random protocols and stuff like that. And what we've got, this is sort of sales pitch territory again. What I'm trying to say is that we've got local and remote, we've got actors, active objects, we've got agents. Remember I mentioned these two were varieties of this beastie here. They're different, they're used differently, but they're varieties of the same thing. And then the data flow operators, a very different way of working, fixed synchronization properties, things like that. And now what we've got in our Groovy community is local, we always had those, now we've got remote versions. So you can think of this in a diagrammatic form. Apologies. NUMA, non-uniform memory architectures. No, you see, you're not CPU-bound people. You're I/O-bound people, aren't you? You like input-output. Me, if the computer's not flat out, I'm really not interested. I/O is what you do at the beginning and at the end. And melting processors is what you do in the middle. And this idea of non-uniform memory architecture is an integral part of all that these days, with cores, multi-cores, multiple processors, and clusters. But there's an analogy now for what we do, because we're entering the realms of clustering. We're putting JVMs together in a small network. And so the analogy here is that we've got local and remote into a diagrammatic form. This one is for data flow, but you can do exactly the same with an actor diagram. Each of these boundaries represents a particular JVM. You can have data flow operators or actors within a JVM, and you can have multiple JVMs. So communications cost is what it's all about. When it comes to design of these systems, this is expensive. This is cheap. And so that becomes your design principle when you're looking at these sorts of things. Okay, so that was the sort of corporate sales pitch. We've got a few minutes. I think what we should do is a little fun game. Has anybody got a computer that works on the network? I finally managed to get one. It's down here, and the interesting information, see the font size is just not big enough, is that I am 138.4.167.127. So we now know you're going to bombard me, aren't you? Rats. I will lift my firewall. Dangerous. So sudo firewall stop. Clearing firewall. Right, so that was step one. So you now know who I am. Now if you go to my website, hello Bob. If you go to my website and you have Git available, then I have a number. The demo gods have struck, and they have struck down my connection to the internet. This is going to be a very sad game, because the idea was that you folks would run the players, I would run the server, and we'd show it's not me smoke and mirrors here. It was actually really doing multiple JVMs across the network. But I'm going to have to do it the sad way. Sorry about this. Where we go? Ping pong actors. No, we didn't want that. We wanted the conference game. So I can set up the server. Now what I've been hoping you folk could do was be players. So let me actually set both of these up. If you get the Git repository, you can play this game at home. One person or many people could be the players and so on and so forth. So let me just be a player. Over here, server's ready. And let me be a player here. hit the right key. Now sadly, because I'm running both of these on one machine, you can't tell one from the other. If people had been hitting my machine, brilliant, 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 brilliant. The homework for you is to find out why that happens. It shouldn't. And I haven't a clue why at this time. So there you are. I'm going to end, or bring this session to an end on failure. Because the sales pitch is, your Gpars needs you. In the same way that Groovy needs you, Gpars needs you, because we haven't got any funding for anybody to do any work. So we're reliant on volunteer work. And I shall be putting this up onto the, we have no idea where our gyro is going. So if anybody knows how to move gyros from Codehouse to Atlassian, we need your help like 2 weeks ago. So next week would be great. So just to round this little session off, it was a sales pitch. Hopefully it taught you something new that you wanted to know, and you didn't have to pay for it. That's bad selling. So it's marketing. It's been more of a marketing pitch, really, for a new feature we brought in middle of last year, thanks to Google for funding it. It really was a pleasure to work with Russel, who was a superb student on that. Great experience mentoring him. And as ever, when you mentor these things, you also learn something. So that was really good. And if any people want to use this stuff, feel free. If you get any bugs, we will eventually have a bug reporting system at some point. Please do get involved. And at that point, I'll take any questions that you might have.
Could you talk a bit more about remove data flow variables? How they works?
Okay, I repeat the question because it's then going on to the video. So it's asking just a little bit more about how the remote data flows work. Let me go back to, to this diagram here. So this is sending something to here, and that's happening over Netty. This data flow operator is sitting idle on the reception of some data. It doesn't care whether it comes locally or remotely. It's the arrival of the data that matters. The fact that it's coming over Netty makes no difference. This data flow operator here, it's, I won't say thread because this is all sitting on thread pools. Each of these are tasks on a thread pool. But this task is blocked awaiting data on its channel coming in. It doesn't care where it comes from, but it will only trigger when this one has triggered and sent something down that channel. So has that given you the extra little bit you're after? Yeah, these channels are set up as part of computation. So if you go and have a look at the code examples, you'll see that I create a data flow queue, create a data flow queue. This is a data flow queue. That is a remote data flow queue. It comes from a different package. By coming in from that different package, it brings in all the Netty IPC things that it then needs. As far as you're concerned, it's just another data flow queue that you can connected to that. So it's a form of polymorphism of the right sort. Okay, so let me leave that one there for now. If we want to talk a bit more about it, we can chat over lunch. Any other thoughts, comments, questions? Tomatoes being thrown are not allowed. Yes, sir.
Can you distribute the code from the server to the client?
The question here is, can we distribute the code from servers to clients? You can ship anything that's serializable. And so the usual rules apply, that anything that's sent down the line, you have to be able to reconstruct at the other end. So the other end must already have the code, the classes, to be able to then reconstruct the message from serialization. And that's why I was using the serialization in the player ball and the ball type. So it's marking them that they have to be serializable. You have to know about the class at the other end. But otherwise, anything can be sent down the line. So I'll pause that one for a moment because I'm spotting another question over there which I think may be related.
Yeah, it's actually related. So the code that has to be sent across the wire has to be serializable. I guess that you're using, well, the system is using the Java serialization mechanism. My question is, can these be changed to something else, for example, Cry, which is way faster than Java serialization?
So the comment being made here is, can we change this from Java serialization to a different form of serialization? And the answer is whatever Netty does at the moment. So we are sitting over Netty and assuming that whatever it can do. So the answer is I don't know at the moment. We have to try and experiment and see what happens. Okay, well I think we've reached lunchtime. Gurgling is probably happening in the regions between there and there. So at this point I'll thank you for listening and laughing at the right moments, which was great. And vote for ball. Thank you very much.